You are listening to Built for Nature, an exploration of how humans are designed to live through first principles, light, water, magnetism, and the deeper forces that shape human biology. We often think of biology as chemistry, molecules bumping into molecules, enzymes fitting into receptors. But what if that's only half the story? What if the most important processes in your body aren't just chemical, but physical, specifically quantum physical? So in this episode, we're going to go a little deeper. We're looking at the invisible field that surrounds us and the invisible forces that operate within us. We're drawing on insights from the book Life on the Edge by Johnjoe McFadden and Jim Al-Khalili, and expanding that picture with recent discussions on planetary magnetism and human health. So to begin, what does quantum biology even mean? When most people hear quantum, they think of subatomic particles, strange probabilities, things behaving in ways that don't make intuitive sense. Biology, on the other hand, feels concrete. For a long time, scientists assumed these two worlds were separate. Quantum effects were thought to be too fragile to survive inside warm, wet, chaotic living systems. But Life on the Edge challenges that assumption. It presents evidence that certain biological systems actually depend on quantum effects to function efficiently. Take photosynthesis. When light hits a plant, energy needs to be transferred through a network of molecules to a reaction center. In classical terms, that energy should bounce around randomly, but it doesn't. It finds the most efficient path almost instantly. The explanation is quantum coherence. The energy behaves like a wave, exploring multiple paths at once, and then collapsing into the most efficient route. This allows plants to capture and use light with remarkable efficiency, and it hints at something deeper. Life may be using quantum mechanics to optimize energy flow. Or consider enzymes. They speed up chemical reactions in the body, sometimes by factors of millions. In certain cases, this speed may be explained by quantum tunneling. Instead of going over an energy barrier, particles pass directly through it. This may be happening inside your body constantly, not as a rare exception, but as a built-in feature of biology. So if life operates on these delicate quantum scales, what happens when the environment changes? This is where the picture expands from the microscopic to the planetary. Recent data is now showing that the Earth's magnetic field is undergoing significant shifts. Historically, we viewed the magnetic field as a stable shield, but data from the last few decades indicates a rapid change. The magnetic North Pole has moved significantly from Canada towards Siberia. In some regions, the magnetic intensity has increased dramatically, while in others, like the South Atlantic Anomaly, the field is weakening and expanding. Why does this matter for biology? Because biology is far more sensitive to electromagnetic fields than most people realize. Birds, for example, navigate using specialized proteins in their eyes that rely on quantum entanglement to sense the Earth's magnetic field. If the field shifts, the map changes. And if the map changes, the organism must adapt. And it's not just birds. Bees rely on these magnetic cues to orient their hives and navigate foraging routes. Sharks, with their electroreceptive organs, detect the subtle electrical currents generated by the movement of water through the magnetic field. Even humans, though we may not consciously see the field, possess a biological architecture deeply tuned to it. From the way our blood flows to the structure of our brain's ventricles, we are built to interact with this planetary force. When the field becomes unstable, it's not just a navigation error for a bird. It's a fundamental disruption to the physics of life itself. This connects back to the core idea of life on the edge. Life operates at the edge of what physics allows, balancing order and chaos, precision and probability. But if the external field becomes unstable, does the internal field follow? Some researchers propose that the Earth's magnetic dynamo is coupled to oxygenation and isotopic balance. The theory suggests that when magnetic flux changes, it affects how water behaves in the body. Specifically, it relates to deuterium, a heavier isotope of hydrogen. In a stable magnetic environment, biological systems are designed to fractionate water, keeping the lighter hydrogen isotopes for cellular processes and pushing the heavier ones out. This process relies on vortexes in the heart, in the brain, and in the mitochondria. You can think of it as a human GPS system built around these vortexes. The heart acts as a gravity well. The brain creates fluid dynamics in the ventricles. When the external magnetic field is strong and stable, these vortexes spin efficiently. When the field declines or becomes chaotic, the viscosity of the fluids can change. The result is a system that struggles to clear waste, to transport oxygen, and to maintain the precise conditions mitochondria need to produce energy. Okay, so that's a lot. So what does this all mean for human health? It reinforces something that we've seen across multiple frameworks. Biology thrives in coherent, stable environments, and it struggles in chaotic, mismatched ones. This doesn't mean you need to understand quantum mechanics to apply this. The takeaway is simpler. Your biology is more precise and sensitive than you think, and it's more dependent on clean, consistent inputs than you think. Things like consistent light exposure, stable circadian rhythm, metabolic health, low chronic stress, and time outside of natural environments. These are common themes that keep coming up, and there's an important reason for that. They're not just lifestyle preferences, they're biological inputs that help preserve the conditions where biological processes can operate efficiently. Whether it's the quantum coherence in a leaf capturing sunlight or the vortex in your heart pumping blood, the principle remains the same. Efficiency requires stability. Precision requires a coherent field. Life on the edge ultimately expands your perspective. It helps move you from biology as chemistry to biology as physics, energy, waves, probabilities, precision. And when you see life that way, health becomes less about isolated fixes and more about preserving the conditions that allow life to function as it was designed to. Here's the big takeaway. Life operates at the edge of what physics allows, balancing order and chaos, stability and fluctuation. And that means something important for how we live. The more we support stable, coherent environments, the more we support the systems that keep us alive at the deepest level. Thanks for listening.